All right, here we begin. Lesson 1, solve one-step addition and subtraction equations. So in this chapter, we are going to be solving only equations, which means an equation is a sentence stating that two quantities are equal. And this is really helpful to look at the algebra tile illustration. This expression is equivalent to this expression. And what we're going to be solving is for the variable. In this case, we have an x. We start with x plus 2 equals 6, and algebraically that equation is written over here like that, which represents what we see in the picture. In order to solve for the value of x, we have to get rid of these two tiles. And so getting rid of them means that we're going to subtract them. And to keep it equal, we have to also subtract or take away two tiles from this side. Algebraically, it looks like this. Now we start with addition, and in order to isolate and solve for that x, notice that we're using the inverse operations. So that's what we're going to be doing every time we solve an equation, is using the inverse or the opposite operation. All right, let's go down here at this set of problems. It says circle the equations below that are equivalent to x equals 3. All right, well, let's start with this one here, and we'll write it out. X plus 3 equals 6. Well, in order to isolate that variable, we have to get rid of the 3. Get rid of means we're taking away, we're subtracting. And we see subtraction as the inverse operation of addition. We also need to keep it equal, or we say balanced, so that means that you're going to subtract 3 from the 6. When we do that, we have isolated the x, right? The x is all by itself, so we have a solution now for x. X equals 3. All right, so what we are really looking for, well, here, we can circle this one. Okay, so what we're looking for is using the inverse operation, and using the inverse operation on both sides of the equal sign. So here we would subtract 3, and then we would subtract 3. Well, 3 take away 3 is 0. Well, x equals 0 is not what we're looking for. We're looking for x equals 3. So let's keep going. Here we're going to subtract 1, and then we're going to subtract 1. 6 take away 1 is 5. Oh, can't circle that one. We're going to take away 1, take away 1. Yeah, 4 take away 1 is 3, so that one we can circle. Over here we're going to take away 6. Over here we'll take away 6. 8 take away 6 is 2. Nope, that one doesn't work. Subtract 2, 5, and we take 2 away. Yeah, that equals 3. So these 3 equations are also equivalent to x equals 3. All right, let's move on to the video games. Robin had some video games, and then she bought 4 more games. Now she has 10 games. This scenario can be described using the equation x plus 4 equals 10. All right, we have 2 questions to answer. The first one is, what does x represent in the equation? Well, let's read the problem again. Robin had some video games, so we don't have a number for that. So x represents the number of video games that Robin has, and that's the number we don't know. Write 2 different equations that are equivalent to x plus 4 equals 10. All right, well, the first way we could do that is using that inverse operation. So the opposite of adding is to subtract. So we're going to subtract 4 on both sides of that equal sign to keep it equal. That gives us our solution, or we say isolate the variable x equals 6. All right, so that's one way. There's so many other different equations, but here's another. We could add a 2 coefficient to our x. So we have 2 times x equals 12. And that would still keep it at x equals 6. So if we did the opposite or the inverse of multiplication, that would be division. And now we have isolated the variable x. 12 divided by 2 equals 6. All right, so both of those are two different equations that are equivalent. Okay, All right, so up here we are naming the property. The subtraction property of equation states that the two sides of an equation remain equal when you subtract the same number of each side. And if we look down here, here's what that property looks like algebraically. We would just, know that also as inverse operation. So if we have x plus 6 equals 4, and we want to isolate the variable x, we can use the subtraction property of equality. We're going to subtract 6, and we're going to keep it equal by subtracting both sides of that equal sign. And we get our answer of x equals -2, because right here we had 4 take away 6 equals -2. Now, what I do want you to be practicing throughout this whole chapter is checking your solutions using substitution. So we're now going to substitute our answer, -2, add that 6 equals 4, and we see that yes, the sentence is true or the equation is true. So we know that we have solved the problem correctly. Always very important for us to have a way to check our solutions. All right, number 2, we have -5 equals b plus 8. Notice that we want to isolate the b, so we're starting over here. We want to subtract out the 8 on both sides. -5 take away 8 is -13. So double check your work. We're going to still have lots of negatives in this chapter, and there's room for error there. So slow it down, double check your work. Here is where substitution is going to help you. If you made a mistake with your negative positive, you'll catch it here when you substitute. So substitute the -13, add, and it's equivalent. Let's practice with a few of the got it problems. All right, so y plus 6 equals 9. We're going to subtract out 6 on both sides. Y equals 9 take away 6 is 3. When we substitute and we write it back in, 3 plus 6 is 9. 9 equals 9, so we know we've solved that correctly. X plus 3 equals 1. We're going to subtract the 3 on both sides. X equals 1 take away 3 is -2. So let's substitute. -2 plus 3 equals 1. Yep, -2 plus 3 equals 1. 1 equals 1. -3 equals a plus 4. Well, we want to isolate that a, so that means you're going to subtract the 4 on both sides of the equal sign. -3, and you take away 4 more, altogether that's -7 equals a. And then when we substitute, -3 equals -7 plus 4. -7 plus 4 equals -3. -3 equals -3. All right, let's move over on to the next page. Here's a story problem. An angelfish can grow to be 12 inches long. If an angelfish is 8.5 inches longer than a clownfish, how long is a clownfish? All right, well, here's our words. And then we know that an angelfish is 8.5 inches longer than a clownfish. Well, what we don't know is how long is a clownfish. So we could let C represent the length of a clownfish. So an angelfish is 12 inches, right? Equals means is. So we're at is 12. That's the angelfish. Now, the clownfish we don't know. But we do know that the angelfish is 8.5 inches longer than the clownfish. So we've put all that information together into an algebraic equation, and using our subtraction property or inverse operations, we can easily answer how long is the clownfish. We're going to subtract 8.5 on both sides of that equal sign, and that gives us an answer of 3.5. So the clownfish is 3.5 inches long. Let's do a practice problem. The highest recorded temperature in Wausau, Missouri is 118 degrees. This is 158 degrees greater than the city's lowest recorded temperature. Find the lowest recorded temperature. So let's start with the information that's been given to us. The highest recorded temperature is 118 degrees. So 118 equals, this is 58 degrees greater than the city's lowest. So 158 degrees is greater than, which means we're going to add, and what we don't know is the lowest recording temperature. I'll use a T for temperature. So we're going to use our inverse operations, and we're going to subtract 158 from both sides of the equal sign. 118, and we're subtracting 158. The difference is negative 40 degrees and Fahrenheit, so a capital F. All right. Now we switch to this addition property of equality, which states that the two sides of an equation remain equal when you add the same number to each side. So algebraically, what that means is that we are going to use the inverse operation. When we have a subtraction in our equation, we are going to use addition in order to isolate that variable. So x minus 2 equals 1. We use that addition property, inverse operation. We add 2 on both sides of that equal sign. 1 plus 2 equals 3. X equals 3. Use substitution and send the 3 right into the equation to check that you have solved correctly. 3 take away 2 equals 1. 1 equals 1. All right, let's practice this with the goddess. Y minus 3 plus 4. Well, instead of subtracting 3, we're going to add 3 on both sides. 4 plus 3 is 7. Y equals 7. If we substitute it back in, right here, we have 7. 7 take away 3 equals 4. 4 equals 4. So we've solved that correctly. R minus 4 equals negative 2. We're going to add 4 on both sides of the equal sign. R equals negative 2 plus 4 is positive 2. And then again, we'll use substitution. Take this 2 and put it into the equation. 2 take away 4 equals negative 2. Q minus 8 equals negative 9. Inverse operation, we'll add 8 on both sides of the equal sign. Q equals negative 9. We're adding positive 8. Our answer is negative 1. There we go. Take this negative 1, substitute it. Negative 1, and we subtract 8 more equals negative 9. Hey, another story problem. A pair of shoes costs $25. This is $14 less than the cost of a pair of jeans. Find the cost of the pair of jeans. So start with what we have been given. We know that a pair of shoes is $25. That cost of shoes is $14 less than jeans. We can use J for jeans, and we're subtracting because the cost is less than. We use inverse operations to isolate that variable of J. So we're adding 14. And we have an answer of 39. So $39. Make sure in a story situation that you're labeling. So $sign for our answer. All right, let's give H a try. The average lifespan of a tiger is 17 years. So here's what we know. We have 17 years is a tiger. That 17 is 3 years less than the average lifespan of a lion. Write and solve an equation for lion. So 17 is 3 years less than. Less than means that we're going to subtract, but we're subtracting from the average lifespan of a lion. So we could use L for lion. We're going to use our inverse operations, or that addition property of equality. So that means we're going to add 3, and we're going to add 3. 17 plus 3 is 20. So we're going to write 20. We're going to label it years. Let's look at the guided practice, and then we'll be done, and you'll have a chance to practice some problems on your own. Number 1 is n plus 6 equals 8. Thinking inverse operations, we're going to subtract 6 on both sides of the equal sign. 8 take away 6 is 2. When you substitute it back in, what you're doing, which we've practiced over and over again in class, is you're just going to send it right back into that equation just to check. 2 plus 6 equals 8. And these numbers are really easy to work with. So it's not that we have to rewrite it, but sometimes we're going to have to do that to check our work. 7 equals y plus 2. We're going to isolate that y. So we're going to subtract out the 2 on both sides of the equal sign. 7 take away 2, 5. 5 equals y. Now imagine substituting this 5, send it right back in, double check your work. 5 plus 2 equals 7. 7 equals 7. So we did that one correctly. Then negative 7 equals c minus 6. Isolate that variable of c by adding the 6 and adding the 6. Why that works, of course, on this side is that we have 0 pairs. Negative 6 plus 6 is 0. So now over here we have to add negative 7 plus 6, which is negative 1. So negative 1 equals c. And then one last time, let's substitute. Let's send this negative 1 into the equation. Negative 1, and you take away 6 more, equals negative 7. So that's equal. All right, let's finish up with this last story problem. Orville and Wilbur Wright made the first airplane flights in 1903. Wilbur's flight was 364 feet. Okay, so it was 364 feet, and that was 120 feet longer than Orville's flight. Write an equation to represent the flights. So we don't know how long Orville's flight was. I don't know if an O is the best for that. Looks like a 0. We could just use F for flight. But we do know that Wilbur's flight was 120 feet longer. So that means we are going to add that 120. To solve the problem, we're going to subtract 120 on both sides of that equal sign. And our difference here, I'll just write it down here, is 244 feet. Okay, I think that you are going to be ready to move on to your independent practice.